lecture number 4. We are going to study surface tension. Surface tension. Here you see the free surface of liquid have a tendency to minimize its surface area, and that tendency is called as surface tension. That means we consider, suppose for example, mercury falls on ground or floor. It gets split into smaller spherical droplets so that the total surface area is minimum. First example, mercury. Whenever it falls on floor, then it gets splits up into spherical droplets because sphere has minimum surface area. Second, also raindrops are spherical in shape. Or third example we consider, when a gauged steel needle is placed on water surface, then it floats on water surface. All these examples shows that the free surface is always under tension called as surface tension. That means mercury drops are spherical in shape, raindrops are spherical in shape, gauged steel needle floats on the water surface, and all these are the examples of surface tension. Now we will consider here behavior of the liquid surface, and before that we consider, that is behavior of liquid surfaces. Behavior of liquid surfaces. Here the phenomena of surface tension is explained by using intermolecular forces. Here we consider two types of forces: cohesive force, and second one, adhesive force. We will see one by one. Cohesive force, it is the force of attraction between same type of molecules. Force of attraction between same types of molecules is called as cohesive force. And adhesive force, the force of attraction between different types of molecules. Here you see cohesive force, for same type of molecules, force of attraction between same types of molecules. Suppose you consider two water molecules together, then the force of attraction between two water, kerosene, whatever may be, same type of molecules, that is called as cohesive force. Adhesive force means the force of attraction between different types of molecules. Suppose we consider here this ink of this pen stitched to the blackboard or whiteboard, then the force of attraction between this ink molecule and molecule of the whiteboard, this is called as adhesive force. I hope you all understand this cohesive, what is meant by cohesive and what is meant by adhesive. Now we will consider another one definition, that is third definition, range of molecular attraction. We denote by R. Third definition, range of molecular attraction. This is the maximum distance around the molecule up to which intermolecular forces are effective, is called as range of molecular attraction. Suppose you consider this is the molecule, then maximum distance around the molecule. Suppose this is the maximum distance. this much, this much, this much in all directions. Maximum distance around the molecule up to which intermolecular forces are effective is called as range of molecular attraction. Now we consider fourth definition, sphere of influence. Sphere of influence. Suppose we consider this is the molecule, and suppose we draw a imaginary sphere around the molecule, such as molecule at the center, and radius of this sphere is equal to range of molecular attraction. Then this imaginary sphere is called as sphere of influence. An imaginary sphere drawn around a molecule, such as molecule at the center, and radius is equal to range of molecular attraction. This is called as sphere of influence. All these definitions are here we use all these definitions to explain the behavior of liquid surfaces, that is cohesive force, that is force of attraction between same types of molecules, adhesive force, the force of attraction between different types of molecules. Third one, range of molecular attraction. It is the maximum distance around the molecule up to which the intermolecular force is effective. That distance is called as range of molecular attraction. And fourth one, that is sphere of influence. That is, if we draw an imaginary sphere around the molecule, such as molecule at the center, and radius is equal to range of molecular attraction, that imaginary sphere is called as sphere of influence. Now we will consider, we have to see the behavior of liquid surface. For that, suppose I consider another diagram. Suppose you consider this is the container, this is the container, and in this container we consider a liquid is placed. Suppose this is the liquid surface, we consider all these are the liquid molecules. Okay, this is the liquid surface, liquid molecules, liquid is placed in a container. Now we consider here all these are the liquid molecules. Liquid is placed in the container. Now we consider here we consider three molecules in this liquid. Suppose this is molecule A. Then suppose this is the sphere of influence of the molecule A. That is, the sphere of influence is completely inside the liquid. Now we consider another molecule here. Suppose this is molecule B, whose sphere of influence, major part of the sphere of influence is inside the liquid. And I consider third one. Suppose this is the third molecule, molecule C, whose sphere of influence is half in air and half in liquid. Here we consider this is the air and this is the, we consider suppose liquid water. We consider three molecules. Molecule A, whose sphere of influence is totally inside the liquid. Molecule B, whose sphere of influence, whose bigger part is in liquid, smaller part in air. And third molecule C, whose sphere of influence is half in air and half in liquid. Now molecule A is attracted equally in all directions with equal force, that is cohesive force. Suppose I consider only four directions. This molecule is attracted in this direction, upward direction, downward direction, this direction, this direction. That means this molecule is surrounded in all directions with all liquid molecules, water molecules. Therefore all these forces are cohesive forces and they are equal. And if we consider pairing of this, suppose this and this, they cancels with each other. This cancels with this cancels with this, this cancels with this. That means here the net force on molecule A is 0. That means if we obtain the resultant of all, the net force on molecule A is 0. Now we consider for molecule B. This molecule we consider, suppose these are the forces. These are the forces. These are the forces. These are all cohesive forces. And here we consider in this part there are air molecules, upper part. Then there is adhesive force. But we consider here air molecules in this part, they are less in number as compared to liquid molecules. And therefore, net force on this molecule B, if we obtain the vector sum of all the forces, or if we obtain the resultant of all the forces, then this molecule is net force on molecule B is also in downward direction. Now, if we consider for molecule C, half sphere of influence is in air and half in liquid. Then air molecule in this half part, we consider this. Air molecules in this half part, they are less in number, therefore we consider adhesive force due to all these air molecules, this is less as compared to cohesive force, and therefore the resultant force on this molecule C, if we obtain the resultant of all these, then the resultant force on the molecule C is in the downward direction. That means we consider here, suppose this total area of the liquid is, this is the total area. Now if we have to increase the surface area of this liquid, then suppose on this area, suppose n be the number of molecules of liquid, and if we have to increase the surface area of this liquid surface, then we have to brought some molecules which are inside the liquid on the surface of liquid. Do you understand? That means suppose for this surface of liquid, n be the number of molecules, and if we have to increase the surface area of this liquid, then we have to increase the number of molecules, and that number is greater than this, okay, greater than n. That is, number of molecules are greater, suppose n dash. We have to increase the number of molecules than n, and for that we have to bring some molecules which are inside the liquid on the surface of liquid, and for that we have to do some work against these forces, which are in the downward direction. And that work done to bring the some molecules which are inside the liquid on the top surface of liquid, that work done is stored in that surface in the form of potential energy. We have to do some work, and that work done is stored in that surface in the form of potential energy. And natural tendency of anything, either liquid surface or any, natural tendency is to decrease the PE. That means that natural tendency to decrease the PE opposes that, and so liquid have a tendency to minimize its surface area, and that tendency we call it as a surface tension. Any liquid surface have a tendency to minimize its surface area, that means to decrease the potential energy. That means any liquid surface is always under the tension, and that tension we call it as a surface tension. I hope you all understand this. That means what is meant by surface tension. Now we will consider here that is a surface energy and surface tension in the next lecture. Thank you.